Okay, let's try the permutation and combination part of the probability part here. Let's just try it. Consider the word product. So the product has 1, 2, 3, 4, 5, 6, 7 distinct letters. How many arrangements are possible when if all the letters are used? Well, a lot of people just know, and a lot of people got these 2 marks because they knew it was 7 factorial. But why is it? Well, when you start off, you have 7 choices, then 6 choices, then 5, 4, 3, 2, and finally, after you've used 6 letters, you have only 1 choice left. So 7 times 6 times 5, it's 5,040. There's that nice button for you've got 7 letters in choosing in 7 places, 7P7. That nice button on your calculator that'll give you the answer quickly as well. Well, let's try the next question. How many different arrangements can be made if the first letter is a T? Well, the way to do this is just to think, if I start with a T, there's only one way I can do that. There isn't 2 T's or anything going on. There's 1 T, so that box is finished. Now, if I finish with a C, there's only one way you can do that. So you're locked in. It's one choice. 1 times this, 1 times this. Now you think, okay, I've used up the C and the T. How many letters are finished? 1, 2, 3, 4, 5. I'll have 5 choices. So I don't have any choices with the T and C locked in like that. But then I have 5 letters left. And then once I choose a letter, I'll have 4, then 3, then 2, then 1, 5 factorial, or 5 choose 5. And you'll see on your calculator, I think it's the NPR. How many letters can you put in that many places? Yeah, N choose R, that's the button. Anyways, 5 factorials, 120. So those are pretty straightforward marks, you guys. We should get them. Now the next question is harder, but it really isn't so incredibly hard if you just go through it. And you use these boxes as choices. There's 7 letters, but they tell you something. What if we took the letters R, O, D, and they have to follow each other? So what you kind of think like is, okay, R, O, and D, I'm going to put a rope around them, and those 3 boxes are going to become one box. They're really one deal altogether. But there's R, O, D. There's 3 ways times 2 times 1. There's 6 ways I can arrange this. 3 factorial. That's why there's 3 factorial there. And you get a mark for that. But if I use up these 3 letters, so there's 3 ways you could do that, but they kind of act as one choice. So 1 letter together. And then there's the R and the O and the D. There still is 1, 2, 3, 4 more letters. So together there's like 5 boxes because the rod guy kind of counts as 1. That's why it's 5 factorial. So when you start, you've got 5 different things you can put there. Any one of the 4 letters or the ROD combination. And then after you've made a choice, there's 1 more left. And then 1 less. There's 4, then 3, then 2, then 1. That's why it's 5 factorial. And 3 factorial times 5 factorial is 720.